All right, let's talk about the magic that makes AI feel, well, instant. This isn't about some far-off prediction of the future. It's about predicting what's happening right now. I mean, have you ever really thought about this? You tap your card to pay for a coffee, and that's it. It's approved. But in that split second, your bank's AI just ran a check to make sure it was really you. So how on earth is that possible? That incredible speed is exactly what we're going to dive into. To really get why instant is such a revolution, we have to look at how things used to be done. We have to talk about the problem of waiting, where getting an answer later was just the way it was. For the longest time, AI was kind of like a night owl. It would just chug away in the background, crunching huge piles of data overnight. Then you'd come into work the next morning and find a report waiting for you. This whole process is called batch inference. It's powerful, for sure, but fast? Not even close. And when you put them side by side, the difference is just staggering. With batch inference, you're waiting minutes, hours, sometimes even days for a result. With real-time inference, we're talking milliseconds. It's the massive leap from planning for tomorrow to reacting right this second. It's what turns AI from a static report into a living, breathing part of an app. So, this brings us to the hero of the story, real-time inference. This is the tech that makes on-demand predictions a reality, giving you an answer at the very moment you need it. So what is it, really? Well, it's pretty straightforward. It's about making a prediction the instant new data shows up. We're not waiting for a big pile of information to accumulate. A single thing happens. You click a button, you tap your card, a sensor gets a reading, and boom, a prediction comes right back. But here's the catch. Not just any AI model can pull this off. A real-time model has to be a finely tuned machine, kind of like a Formula One car. It needs to load into memory in a flash, process data on the fly, be super accurate, and it has to handle thousands of these requests every single second without even breaking a sweat. And this isn't some futuristic tech we're talking about. The most fascinating part is that you are already using real-time inference every single day, probably without even noticing it. Just think about it. That fraud detection we talked about? Classic example. But so are those product recommendations that pop up the moment you look at something online, or the chatbot that actually has a helpful answer for you right away. Even the shows Netflix suggests for you. It's all being powered by this engine of instant prediction. So, how does the magic trick actually happen? Let's pop the hood for a second and take a look at the journey of one of these predictions. It's actually a surprisingly quick trip. Okay, so it all starts with you. Step 1, you do something, like make a purchase. In step 2, that data gets sent off as an API request. Think of it like a digital messenger. Step 3, a preloaded AI model that's just waiting ready to go grabs that data. Then, step 4, it instantly makes a call, fraud or not fraud. And finally, step 5, that answer gets sent right back to you. The entire round trip is over in the blink of an eye. Now, to make all this happen, you need the right set of tools. You've got API servers like FastAPI to handle all the incoming requests. You've got containerization tools like Docker to package everything up neatly. Then you need an orchestrator like Kubernetes, which is like the conductor of the orchestra, making sure thousands of these requests are handled smoothly. And the whole show usually runs on big cloud platforms from Amazon, Microsoft, or Google. But look, getting that millisecond speed over and over again isn't easy. It's a real challenge. But luckily, engineers have come up with some pretty clever ways to make these systems both fast and reliable. So for instance, the #1 enemy is latency, which is just a fancy word for delay. To beat it, engineers use powerful GPUs or clever tricks to make the models smaller and faster. Then you have to deal with sudden spikes in traffic. The solution there is to use cloud tools that can automatically scale up. And what happens when the model gets a bit stale? That's called model drift. The fix is to constantly monitor its performance and retrain it with fresh data to keep it sharp. When it comes to pure speed, one of the biggest pro tips is to preload the model in memory. It's just like a chef who preps all their ingredients before the dinner rush. The model is right there, ready to go, so you don't waste precious time fetching it for every single request. It's all about being prepared. Okay, so let's pull all of this together. We've seen what real-time inference is, where it lives, and how it works. But what's the big takeaway here? Why does this matter so much? Here's what you really need to remember. Real-time inference is what makes AI feel alive and interactive. It's the engine behind things like chatbots and instant fraud alerts.
Building it requires a serious focus on speed, scaling, and good engineering practices called MLOps. And ultimately, its impact is immediate, creating better, faster, and safer experiences for all of us.
And if you take just one thing away from all this, let it be this. It just nails the entire concept. Batch ML predicts tomorrow. Real-time ML predicts now.
Which leaves us with a final, really interesting question to chew on. We've watched AI make things like fraud detection and personalization instant. As this technology continues to get faster and smarter, what's the next impossible thing that it's going to make happen in the blink of an eye?